Hello, today we are going to present you about the case study of Trali Valley, a sport equipment manufacturer in the United States. The process involved receiving products from multiple suppliers, consolidating them into cross-dock warehouse, and then distributing them to the customer. We want the company to implement a vendor management inventory or VMI system and provide inventory management document. We need to calculate safety stock ordering point and conduct analysis at each location.
After cleaning the data, the next step is to sort the warehouse. To do this, we select column C, which contains the warehouse code, and then we apply sort C to A. Also that all warehouses are grouped clearly. Once the data is sorted, we begin calculating with the value. We need to make calculation easier. We create a new sheet and then we copy the order number from column A. For example, warehouse XYS is 2121223. Warehouse UHY is 1224242488. Warehouse PUJ is 2489233939. Warehouse NMK is 3940264444. Warehouse NBV is 6445-7135 and warehouse NMKL is 7136-7992. We start and copy route A2 to A1223 for warehouse XYS. Intro on new sheet. First step, we copy the total 10 columns, which include order number, sales channel, progress date, order date, shipping date, delivery date, unit price, discount applied, unit cost, and order quantity. After copying this column, we begin our calculation. 1. Unit price multiplied by discount applied equal to discount. 2. Unit price minus discount. Unit price minus discount equal to unit price after discount. 3. Unit price after discount minus unit cost equal to profit per unit. And last one, order quantity multiplied by profit per unit equal to total to each order. The final step is to sum total profit per product for each year by equal to sum column 2 to 1 2 2 3. Sum column 2 n true n 1 2 2 3. This total profit per unit product per each year.
A number 2 is finding average lead time from each warehouse for each customer by each year. We count the lead time from order date and delivery date. Since we already have the order date and delivery date in order, like day 1 of order date is in column 1 of order row, and day 2 of order date is in the column 2 of order row already. And the next thing that we have to do is just highlight the year, like 2018 year is in the yellow highlight, 2019 year is in pink highlight, or something like that, to separate the year more clearly and we will visibly see it to not confused. And now we will find the lead time. Before we find the average, we will find the lead time by input the data of equal date diff DATE followed by the order date number 1 and delivery date number 1, and the last one is followed by D which is come from date to find lead time. And after we got the lead time, we will find the average lead time, since we have to calculate the average out. So we will find the lead time by selecting the number in year 28, 29, and 2020 separately in the data by type equal AVG, which is stand for average. And then we put that number, like the number for year 2018, like that, and enter. Then we will got the number of it. For the example of warehouse XYS, 2018 they got 20.576, 2019 got 20.268, 2020 got 20.429. For warehouse UHY, 2018 they got 19.979, 2019 is 20.767, 2020 is 21.200. For the warehouse MMK, in 2018 they got 20.303, 2019 they got 20.385, 2020 they got 21.264. For the warehouse NBV, 2018 they got 21.672, 2019 they got 20.517, 2020 they got 21.203. And the last warehouse is warehouse MKR, they got 20.435 in 2018, and 2019 they got 20.184, and 2020 they got 20.343. And this is the average lead time of each warehouse. Since we find the average lead time for each warehouse, so we will calculate and do that step for each warehouse.
And now in the part A3, I'm going to explain how we calculate the total discount applied in the dollar value for each sales channel.
We follow step by step. 1. We have select some data in the new sheet that we sort the sales channel. Click in the row of data and click sort and filter. Select sort set to a chart. Now first we sort the sales channel column so that all order belong in the same channel are grouped together. This makes much to work with the data and ensure each very channel is clearly separated. For example, wholesaler, online, in-store, distributor. Then next step, we are calculate sum the discount applied in each channel. In the use function sum in the sum, select discount apply column wholesaler and click OK. No, wholesaler and click OK. Now we have wholesaler 0.88. And now we use sum function, sum in online channel discount apply is 1.41. Install sum, click sum and select column discount apply. Select install 0.75 and distributor and use sum, select 0.95. Then we calculate, since we discount has already been correct into the dollar value for each order, we simply use the sum function in Excel, add them up. So especially we sort the data by channel first and then sum the discount amount for each channel. Especially this script use the total discount applied in dollar is very individual channel. Is complete process the short by channel and the sum discount value for each channel. And this total discount applied in each sales channel in warehouse XYZ and total discount applied in each channel warehouse UHY, and this total discount applied in each channel PUJ, and this total discount applied in each sales channel in MK, and this total discount applied in each channel warehouse NBV, and this the last warehouse MKL total discount in each channel. Yeah, thank you. Next class.
Next, we move on to the regression analysis. In this part, we want to understand whether there is a relationship between discount applied and order quantity. In this model, the discount applied acts as the independent variable and the order quantity is the independent variable. To run the regression in Excel, we follow 4 steps. First, go to the Data tab. and then choose the data analysis and select regression from list. For the input length, set input x to the discount value and input y to the order quantity. This select all. Finally, click OK to generate the results. When we look at the output for each warehouse, most of the results indicate that we cannot reject the null hypothesis. This means the discount doesn't have statistically significant effect on the almost of product order. In other words, even when the discount increases, it does not necessarily lead to higher order quantity. Thank you.
Finally, the ROP is calculated by multiplying average daily demand and average lead time, and then adding the safety stock, which is calculated using the formula Z multiple SD multiple square root lead time. The Z value corresponds to the service level we want. This final ROP value helps us set the point at which a new replenishment order should be placed. By using the ROP model, we can effectively manage inventory level and reduce the risk of stock outs. All of these steps help the company maintain an appropriate inventory level, avoid stock outs, and provide better responsiveness to customer demand. By accurately calculating lead time, average demand, and the reorder point, and company can manage its operations more efficiently and serve customers more effectively.
For the conclusion, this report provides a comprehensive evaluation of Trali Valley's logistic performance, demonstrating how data-driven decision-making can significantly enhance supply chain efficiency through systematic data cleaning, precise metric calculations, and detailed analysis using pivot tables. The study reveals meaningful insight into profitability trends, lead time, valuation, sales channel behavior, and warehouse operations. The results indicate clear pattern in yearly product profitability, difference in average lead time across warehouse and customer groups, and distinct discount structure among wholesale, online, in-store, and distributor channels. These findings reinforce the importance of applying structured data analytics to identify operational bottlenecks and opportunities for improvement. Additionally, the report emphasized the strategic value of vendor managed inventory or VMI in strengthening inventory visibility, reducing stock out, and enabling more accurate demand fulfillment. By integrating VMI with ongoing analytical practice, Trali Valley can further optimize cross-docking operations, streamline workflow efficiency, and improve overall responsiveness to market demand. In conclusion, leveraging advanced analytical tools and well-organized operational data equipped Trali Valley with the insight needed to support sustainable growth, minimize inefficiency, and elevate customer satisfaction within an increasingly competitive logistic landscape.